Hello everybody, in this mini lecture we are going to prove the following statement. Products of affine varieties are affine varieties. Well, actually we are going to prove a statement that is slightly more general, and this is the following lemma. Assume that x cross y has a topology such that the following inclusions are continuous for all p in x and q in y. For every p, j of p is an inclusion from j to x cross y, sending elements b of y to pairs p, b. And for every q in y, iq is an inclusion sending elements a of x to pairs a, q. And given that these inclusions are continuous, we can conclude that x cross y is irreducible. And this is what we are going to prove. This is going to be a proof by contradiction. So assume that we can write x cross y as S1 union S2, where the Si are both unequal to x cross y and are both closed. Then for every p, the image of y under j of p, which is p cross y, has to be irreducible because j of p is continuous and y is irreducible. So p cross y has to lie in S1 or in S2. So we can define sets T of I as the set of points P in X such that P cross Y is a subset of Si. And then we can write X as a union of T1 and T2. But Ti is nothing but the intersection over all Q in Y of the pre-images of the maps IQ of the sets Si. And these are all closed, and so the intersection is closed, and so Ti is closed for I equal to 1 and 2. And going back to this line, we find that we have expressed the irreducible set X as a union of closed sets T1 and T2, which is of course a contradiction. So we can conclude that x cross y is indeed irreducible. Now to prove that the product of affine varieties x, y is an affine variety, we just have to apply this lemma. For every q in y, let the map IQ be the following map, as you can see here. And similarly, for every p in X, we define a map J of p. And both of these maps are regular maps and are thus continuous. And so the statement follows from the lemma. And this concludes this mini lecture. Thank you for watching. See you next time.